This video is about using row reduction. It's also called Gaussian elimination to solve a 4x4 system of equations. This time, we don't do RREF because this way it take too much time. We just want to get this form. Then we can change into system equation to solve 4x4 system of equations. For this pattern, just remember we need 1 first. Then using the 1 to make this 3 equal to 0. Then try to make this 2 equals 0. This is equal 0. Then you stop. To change this matrix into system equation to get the solution. For example, this is the 4x4 system of equations. First of all, we need to change into matrix form. Here is a matrix form for this system equation. Remember, over here is 0y. That's why you get the 0 here. First step, we need to make this part equals 1, which means this number equals 1. Just check the whole system of equation. I got the row 1, row 2, row 3, and row 4. I have a 1 over here, so that I just switch row 1 and row 2. This is the easiest way to make the first row and the first column equals 1. So I have here is 5, 16, 22, 15. This part will be 1, 2, 1, -1, 3, 2, 4, 4, 4, 4, 3, 4, 2, 0, 1, 5. Next step, you need to make all this equal to 0. You got to use this number. Therefore, you will do row 1, you multiply by 3 minus row 2. The row 1 multiply by 4 minus row 3. Row 1 multiply by 2 minus row 4. So that you will get, this is a 1, 0, 0, 0. I have 2, 1, -1, and this is a 5. The first row won't change. Do the operation for row 1 times 3 minus row 2. So 2 times 3 minus 2, here's a 4. 1 times 3 minus 4 is -1. -1 times 3 minus 4 is -7. 5 times 3 minus 16, that's -1. Then we will working on this operation. Row 1 multiplied by 4 minus row 3, it will be 4. 1 times 4 minus 3, that's it's 1. -1 times 4 minus 4, this will be -8. 5 times 4 minus 22, it will be -2. And we go to this operation. The first row times 2 minus row 4. So you get the 4 here. 1 times 2 minus 1 is 1. -1 times 2 minus 5 is -7. 5 times 2 minus 15 will be -5. Then your next step, you will make this 2 equals to 0. We can use row 2 minus row 3 and also the row 2 minus row 4, so that you can get this 2 is a 0. So row 2 minus row 3, you will get here is 0, 0, negative 2, 1, 1. This is a 0, 0, negative 2, here is 0. This is a 4. Next step, we need to make this part equals to 0. Therefore, you will get row 3 minus row 4. The first row don't change. Zero, 4, negative 1, negative 7, negative 1 stay. 0, 0, negative 2, 1, 1 stay. Then we do the subtraction here. You will get 0, 0. This is a 0. This will be 1. Then you get the negative 3. When you get this pattern, then you stop. We will change this into system equation. We know our variable is x, y, z, t. Therefore, this number will be the coefficient for x, y, z, t. You will have from bottom, we will write 0x, 0y, 0z. You have 1t equals negative 3. Then you will have negative 2z plus t equals 1. You have 4y minus z minus 7t equals negative 1. You will have 1x plus 2y plus z minus t equals 5. So from the first one, we can get the t equals negative 3. Then we substitute this t into negative 3. You will get the z equals 4 over negative 2. You will get negative 2. Then from here, we know t is negative 3 and z equals negative 2. So you get the 4y plus 2 plus 21 equals negative 1. Then 4y equals negative 24. So y equals negative 6. Then we will substitute tzy to this equation. You will get y is negative 6, z is negative 2, t is negative 3. Get equation x minus 12 minus 2 plus 3 equals to 5. Then the x equals 19 minus 3 equals 16. So x equals 16. In this way, we already successfully solved 4x4 system of equations.